Hello students, today we are here with a question and the question states like this. A charged metallic sphere A is suspended by a nylon thread. Another charged metallic sphere B is held by an insulating handle and is brought close to A such that the distance between their centers is 10 centimeter. As shown in the figure below, resulting repulsion of A is noted. Sphere A and B touched by uncharged sphere C and D respectively. C and D are then removed and B is brought closer to A to a distance of 0.5 centimeter. Okay, between their centers. What is the expected repulsion of A on the basis of Coulomb's law? Sphere A and C and sphere B and D have identical size. Ignore the sizes of B and A in comparison to the separation between their centers. A and C, B and D, they have same sizes. Okay. Now I'll explain the question first, then we will move on how to solve it. Okay. To understand the question, listen very carefully. We are having a sphere A, sphere B. These both spheres are not identical in their size. Identical in size. Okay, not identical in size. Whereas sphere A and C are identical and sphere B and D is also identical, but A, B not identical, C, D not identical. Okay. In first case, sphere A is fully charged, sphere B is fully charged with respect to themselves. Okay, we are not talking with respect to A or B. Initially they have some charge on it and they are brought closer to each other. How much closer they are brought? 10 centimeter close. Okay. Then they have seen some kind of force, that is force 1, which is here we are having force 1 when they are fully charged and brought 10 centimeter. Next we took A and we kept A along with C, brought close, okay, and B with D. Okay, this is a question. Then we separated. After some time, we separated A from C, B from D and brought again A and B into a single system. Now, what we have done? We have reduced the distance between their centers. Reduced the distance between them. Okay. Now, what is the force between both of them is the question. F1 is sum F. Okay, F1 is equal to F. We know, we can find out. F2 is sum F, which is mysterious to us and we need to find out. We need to compare how much force is reduced or increased after mingling A and B with C and D respectively. Okay. I'll explain this in Hindi also. क्वेश्चन बोल रहा है कि हमारे पास दो स्फीयर है, एक स्फीयर है A और दूसरा स्फीयर है B. अभी A स्फीयर के पास कुछ चार्ज है, B स्फीयर के पास कुछ चार्ज है, तो ये दोनों स्फीयर हो गए चार्ज स्टेट में. Both the spheres are in charge state. Okay. अभी हम इन चार्ज स्टेटेड जो हमारे स्फीयर्स हैं, हम उन्हें एक सिस्टम में लेकर के आए हैं और उन दोनों के सेंटर से जो डिस्टेंस है वो है 10 सेंटीमीटर का. ओके. इसके बाद हमने क्या किया है, हमने ए स्फीयर को स्फीयर सी से मिलाया है और बी स्फीयर को स्फीयर डी से मिलाया है. मिलाने के बाद कुछ समय के बाद में हमने ए स्फीयर और बी स्फीयर को सी स्फीयर और डी स्फीयर रेस्पेक्टिवली क्या किया है, अलग अलग कर दिया है। और उसके बाद हम दोबारा ए और बी स्फीयर को जो है एक ही सिस्टम में लेकर के आए हैं, बट इस टाइम हमने दोनों के बीच का जो डिस्टेंस है उसे आधा कर दिया है, उसे हाफ कर दिया है। फ्रॉम 10 सेंटीमीटर टू 5 सेंटीमीटर वी हैव डिक्रीज्ड। अब हमें ये पता लगाना है कि अब हमारे पास कितना फोर्स आएगा, व्हाट इज द फोर्स बिटवीन ए एंड बी। ओके, now understand it very carefully. This is now I'll be explaining you the solution. जब हमारे पास A और B दो स्फीयर आए थे, they were fully charged. Then we introduced C and D into the system. We allowed A to mingle up with C. तो अभी क्या किया, C was uncharged, D was uncharged. What is the thing? जब दो कोई metallic sphere comes into contact, एक charged है, ओके, एंड दूसरा जो है वो अनचार्ज है, देयर इज नो चार्ज ऑन सेकेंड स्फीयर। तो क्या होगा, वट एवर चार्ज दिस स्फीयर इज हैविंग, उसमें से आधा इसमें चला जाएगा, आधा इसमें चला जाएगा और आधा इसमें बच जाएगा। ठीक है, तो अब ए के साथ भी वही केस हो रहा है और बी के साथ भी वही केस हो रहा है। फ्रॉम द पिक्चर वी कैन सी ए इज हैविंग 4 पॉजिटिव चार्जेस। तो अभी when C comes in contact, A के पास सिर्फ 2 चार्ज रह गया और C के पास 2 चार्ज चला गया। नाउ अब जब B हम देख सकते हैं इन द पिक्चर कि B के पास 2 चार्जेस हैं, पॉजिटिव पॉजिटिव। जब B केम इन कांटेक्ट विद D तो क्या हुआ कि B के पास एक चार्ज रह गया और D के पास एक चार्ज चला गया। नाउ आफ्टर डूइंग ऑल दिस थिंग्स we have separated A और B from C and D. Okay, उन्हें हम एक सिस्टम में लेके आए। अब क्या है, we can compare the system 1 and system 2. यहाँ पे डिस्टेंस ज़्यादा है और यहाँ पे डिस्टेंस कम है, बट यहाँ पे चार्ज भी ज़्यादा है और यहाँ पे चार्ज कम है। फर्स्ट थिंग we need to write the formula. फॉर्मूला क्या है, force equals to constant into Q1 by Q2 divided by R square. Okay. Force is directly proportional to the charge in the system and force is inversely proportional to the distance between the charges in the given system. Abhi what is happening here, charge is reducing, so in this case force will reduce. जब charge reduce हो रहा है तो what will happen to force? Force will also reduce because they are directly proportional. तो charge कितना reduce हुआ है, by half. By half the charge is reduced, तो force कितना reduce होगा, by half. Okay, अभी what is happening in the R? R is also reducing by half, तो force कितना reduce होगा, by 4. Okay, by 4. Sorry, force will not reduce as this R distance is reducing, force will start increasing क्योंकि दे आर इन्वर्सली प्रोपोर्शनल। क्योंकि वो इन्वर्सली प्रोपोर्शनल है तो जितना R कम होगा उतना फोर्स हमारा बढ़ेगा। ठीक है, तो R कितना रिड्यूस हुआ है, R इज रिड्यूस्ड बाय हाफ, R इज रिड्यूस्ड बाय हाफ। तो फिर 2F क्यों नहीं आ रहा है, वाई 2F इजंट कमिंग, क्योंकि R स्क्वायर है, 2 का स्क्वायर कितना होता है, 2 स्क्वायर इज 4. तो व्हाट इज द इंक्रीमेंट इन द फोर्स व्हेन डिस्टेंस इज रिड्यूस्ड बाय हाफ, फोर्स will become 4 times the initial force. Okay, now this is reduction. We'll see this case, come to this case. For 1Q force is reduced by half. Similarly for second Q also force is reduced by half. So what is it, F by 4. See, when charge is reduced, force is reducing by F by 4. When distance is reduced, force is increasing by 4F. When we will combine these two equation, directly proportional wali and inversely proportional wali, we will find the force initial is equals to force final. Okay, so we will move to the next slide where I have given a proper solution for it, so it will be better for you to understand in a written format. I hope I have explained what we will be doing next here in this slide itself. Okay, now see, let the charge of sphere A be QA. Okay, we are not taking any number, we are defining the charge in variable only. It can be 10 units, 15 units, 100 units, 2000 units, anything. Okay, and on sphere B to be QB. Okay, this is initially. Okay, not after coming in contact with C and D. Before coming in contact with C and D, we are having these values. Okay, now the distance given between A and B is 10 centimeter. We will substitute the given values in the given formula. Fi and I is initial force. Okay, initial force. Now sphere A touches C, charge is distributed equally. Okay, charge is distributed equally implies जितना charge A के पास है उसका आधा A में रहेगा और उसका आधा C में चला जाएगा. Similarly, sphere B touches sphere D and again distribution is equal among them. अब after separation हो गया, distance distribution हो गया, then charge on A is Q by 2, charge on B is QB by 2. Substituting these values to find the force final. This is what? This is final force. I'll write final force. What is final force? After A and B came in contact with C and D, उसके बाद जो हम force find out कर रहे हैं, that is final force. Okay. So K is our constant, QA by 2, QB by 2 and 5 to the power 2 inverse square. ठीक है? As this distance is reduced to 5 centimeter. It is given in the question itself. Provided in question. Okay. So we will find the ratio between F initial and F final. Okay, we are comparing F initial divided by F final, KQA by QA, QB by 10 to the power 2, and then what I have did is KQA by QB by R square, the whole divided by KQA by QB, that is by 2 and this is by 2, by R square by 2 in the bracket. Okay, this is what we will get as F initial by F final. Okay, this is what the value will get. So how I did this is, whenever there are P by Q in the format, P by Q format, we are having division. What we do, we keep the upper numerator as such and denominator will put into the multiplication, and here the P by Q format will change into Q by P format once it comes to multiplication operation. Okay, so I have multiplied, I have taken the application of operation of multiplication, and hence this this thing got reversed. Okay, so 5 square by KQA by 2 into QB by 2. Here KK will cancel out, KK will cancel out, QA QB will cancel out as they are same. 1 by 2 will be left, and 5 cross 5 will give 25. What is the square of 5? 25. What is the square of 10? 100. Here it will be left 1 by 2, that is 1 by 4. Again this is in P by Q format. So what is it? It is 25 divided by 1 by 4. In such a case, what we can do is 25 into 4 by 1. This is what we can do. Okay, so what we'll get? 100 upon 1. So this whole turn into 100 also. Here also we are having 100 as denominator, here as numerator, and hence these numerator and denominator cancel out. What is the ratio we are getting for F final by F initial by F final? That is 1. Okay, that is what we are getting. So it states that in case of increasing Okay, just wait a minute. I'll erase and write this statement here properly. Okay. This is quite an important statement which you should always remember for answering uh, like fastly. Okay, I'll just give you the basics. Okay, we'll see whenever we reduce charge, force reduces, charge increased, force is also increased. Okay, similarly when distance between two concerned particles increases, force decreases, and vice versa. Okay, if distance is decreased, then what will happen to force? It will increase. Why it happens so? It happens force is directly proportional to charge but inversely proportional to distance square. Inversely proportional to the square of distance. Okay. So this is an important statement. One should always remember, and if you are remembering this statement, you do not need to follow this lengthy procedure. You can read the question, understand the question, and along with the diagram itself you can solve it out. Okay, this procedure which I have written is for you to understand it. Okay, so that's all for today. This is the question we have done, and hopefully you have understood it. Thank you and bye bye.